Hello, I'm Mr. Malden, and this is the Math Toolbox where I teach you how to become a middle school math master. Our objective today is to add and subtract fractions, and so we're going to get right into this, all right? With just looking at the steps. Adding fractions is really not as complicated as it seems. And by the way, these steps that I'm about to give you, they're for adding fractions, and then subsequently we're going to get to subtracting as well. Do not confuse this with multiplying and dividing fractions. They're not the same. Usually the rules for adding and subtracting are different than the rules from multiplying and dividing. So just remember that, all right? But for adding fractions, our first step is just to make sure that we have the same denominator. So I've started out easy. You've got two fractions right here that have the same denominator. The denominator is 4. That's the bottom number, all right? So that's the first step is you just want to make sure that the denominator is the same. If they're not the same, you can't add the numerators until you have the same denominator, same fraction as the denominator. Sorry, same number, common denominator. All right, step 2 is to then just add the numerators. So if we know that the denominators are the same, well, we want to add the numerators together. So in this case right here, 3 plus 2 is 5, all right? So we made sure that we had the same denominator. They're still fourths, all right? We're going to keep that, all right? And we're just going to add the numerators. So step 2, add the numerators and keep the denominator. And step 3 is just to simply simplify the fraction once you're all done. In this case right here, 5/4 is an improper fraction. And by the way, we're going to talk about converting improper fractions to mixed numbers at the end of this lesson, and then mixed numbers back to improper fractions. Yeah, you want to simplify if necessary. It's not always necessary, but in this case it is. 5/4 becomes 1 1/4. And the simple way to do that is to, let me flip this camera around. There we go, just like that. The simple way to do that, we had 5/4, all right, is to divide the numerator by the denominator, all right. I call this TIBO, all right, which is an acronym for top in, bottom out, all right. Sorry about that glare right there. I'm going to have to fix that. But right, so TIBO, top number goes inside the division bracket, bottom number goes outside, all right. We have 4 goes into 5 one time, all right, and then we got 1 times 4 is 4, 5 minus 4 is 1, so we have a remainder of 1. We want to take that and make a new fraction with that remainder. It's going to be our new numerator, and then our divisor right there, it stays our denominator over there. So 5/4 equals 1 1/4. All right, let's go ahead and move on. All right, so adding fractions with the same denominators is cakewalk. All right, you just simply add the numerators, keep the denominator, and simplify if you need to. All right, let's try this one. All right, so with these examples, I want you to pause the video when you get to an example like this. Try to do it yourself first, okay, and then unpause it and come back and see how I did it. All right, so this one right here, hopefully you paused. Go ahead and pause now if you haven't, and then come back and get the right answer. So I'm going to move forward with it. All right. This one right here, we've got 4/7 plus 2/7. Again, with adding fractions, the first thing we want to make sure is that our denominators are the same, and they are. They're both 7. All right, so that's going to be our denominator for our new fraction. Okay, and we just add the numerators. 4 plus 2 is 6, and 6/7 is our final answer because it cannot be simplified. So that's our final answer, all right? Now let's move on to fractions with a different denominator, all right? Whenever you have fractions with different denominators, like was shown right here, I should have started the video just with 2/3 plus 1/4, so let me show you how it should have looked. 2/3 plus 1/4. All right, you see those are fractions now that we're adding that have different denominators, okay? So the first step we want to have is to make sure that we have the same denominator, all right? In this case, it was 12ths. And the way to do that, all right, it's not very complicated. You just want to make sure you have the same denominator. The fractions are going to be adding over here, right? The easy peasy way to get a fractions with the same denominator is take the denominators that you have and multiply them. So 3 times 4 would be 12, all right, we know that 12, because we just multiplied those two numbers to get 12, we know that 12 will have both of those as factors, all right? And so it'll make it easy for us to be able to convert these to fractions, all right? So I had to multiply 3 by 4 to get to 12, all right? So that means I'm going to have to multiply the numerator by 4 as well to get my new numerator, all right? So if 3 times 4 is 12, then 2 times 4 is 8. So these two fractions, they're the same thing, it's just represented in an unsimplified manner, all right? Now then, I had to multiply 4 times 3 to get 12, all right? So I'm going to have to do the same thing to the numerator, just like that, all right? So 1 times 3 would be 3. Now 1/4 and 3/12 are the same thing, okay? So if you've got fractions with different denominators like this, you need to make sure that you have common denominators and convert those fractions to fractions with common denominators. And then step 2 is still the same. You just add the numerators and keep the denominators. So 8 plus 3 is 11, and 11/12 is our final answer, because step 3 says to simplify if necessary. And we don't need to simplify this because 11 is a prime number. It won't have a factor that's useful anyways, a common factor, right? So 11 and 12 don't share common factors, so you know that that fraction right there is simplified, all right? So let's try one. Have you try one by yourself, all right? So go ahead and add these two fractions together, 1/4 plus 2/3, all right? And see what your answer would be. 1/4 plus 2/3. I just did that same exact one. I'm a goofball. All right. So let's instead of that, let's do a different fraction. I apologize for that. I thought my video was fine. So let's do 2/7 plus 3/5. All right. Add those two fractions together. Go ahead and pause this video now. See if you can add those two fractions together. All right, hopefully you paused it. I'm going to go through my process now, all right? We've got two fractions here that we need to add, so we need to find common denominators for them, all right? The easy peasy way to do that is to multiply the denominators that you have. So 7 times 5 would be 35. So we're going to make fractions with 35 as our denominator, all right? I have to multiply 7 by 5 to get 35, so I'm going to have to do the same thing to the numerator up there. All right, so 2 times 5 is 10. And then I'm going to do the same thing over here. 5 times 7 would be 35, so 3 times 7 would be 21, just like that. And then we can just go ahead and add those numerators straight across. 10 plus 21 is 31, and we'll keep our same denominator, so we have 31 over 35. All right, so adding fractions is pretty simple. You just want to make sure that you have common denominators, all right? Then you just simply add up, convert your fractions to fractions with common denominators, and then you would add up the numerators, and you'd be done. All right. Now let's move on to simplify if you need to, by the way. And now we want to move on to subtraction. All right, so subtracting fractions. Step 1, here's the great thing. Step 1, 2, and 3 are all the same, except we're subtracting instead of adding. So again, we just need to make sure that the denominators are the same. So I have two fractions right here, 3/4 minus 2/4. Those denominators are the same, all right? So if the denominators are the same, then step 2, you can move to step 2, and that's just to simply subtract the numerators and keep the common denominators. So 3/4 minus 2/4 would be 1/4, because 3 minus 2 is 1, and we're going to keep the same denominator. And then we'll simplify if we need to. 1/4 can't be simplified, so it's as simple as it goes. So that's going to be our final answer. So now then, I want you to try this one. Try that one at home. All right, 3/5 minus 1/5. Again, pause this video and try it yourself. I'm going to move forward. So if you're not pausing, then I'm going to go ahead and tell you what the answer is. But go ahead and pause it. Give yourself, the respect that you deserve in trying it yourself. See if you get that self-gratification that you did it right. Okay? So we've got 3/5 minus 1/5. All right, our denominators are the same, so we're going to keep that denominator, and we're just subtracting the numerators. 3 minus 1 is 2. So our final answer would be 2/5. All right. So now what about subtracting fractions with different denominators? All right, we've got an example right up here, 2/3 minus 1/4. Again, you want to make sure that the denominators are the same. So in this case right here, 3 and 4 have 12 as a common denominator because 3 times 4 is 12, all right? Then you want to convert the numerators to match, all right? So if 3 times 4 is 12, 2 times 4 would be 8. And then for 1/4, converting it to 12ths, you have 4 times 3 is 12, so 1 times 3 is 3. Now you have fractions with the same denominator. We can go on to step 2. We're just going to subtract the numerators, and we're going to keep the same denominators. We have 8 minus 3 would be 5, and we're going to keep the same denominator of 12, and to simplify if necessary. Again, this one doesn't need to be simplified because 5 and 12 do not have a common factor that will go multiply up into those. So, all right, you try this one. 1/2 minus 2/9. 1/2 minus 2/9. Pause the video, try it yourself. I'm going to go ahead and move forward with it. All right, 1/2 minus 2/9. First thing I need to do is convert these fractions to have common denominators. So I'm going to multiply 2 times 9 is 18. And just remember that I had to multiply that 2 times 9 to get to that 18. So the 1 times the 9 then for that numerator would be 9/18. All right, and then for converting 2/9 to the 18ths, I had to multiply 9 times 2 to get 18, so I'm going to multiply 2 times 2 to get 4, just like that. Right? So now I have 9/18 minus 4/18. That's a whole lot friendlier problem because I converted to fractions that have the same denominator. All right? 9 minus 4 would be 5, and we're going to keep our same denominator. So our answer is going to be 5/18. Go ahead and just follow through with the animations. Again, all we did was come up with a common denominator, and the way that we did that was multiply 2 times 9 to get that 18. Then I've got to convert that 1/2 to a fraction with 18ths and that 2/9 to a fraction with 18ths, all right? That's where I remembered that in order to get 2 to 18 in a multiplicative kind of way, I had to multiply by 9, so I'm multiplying that 1 times 9. And then the same thing, I'm going to the 2/9. 9 times what equals 18? Times 2, so 2 times 2 would be 4. Then I'm subtract the 9 minus 4, I've got 5 left over, and I'm going to keep my same denominator. Just like that, okay? But what happens if you have fractions, all right, that the second one is larger than the first one? Well, we go back to remembering our rules from subtracting integers. And there's a video, if you'd like to, you can go back to on my channel. You can watch the video for adding and subtracting integers. It's going to be towards the end of that video, so it's a pretty long video. You can go towards the end of it, and you're going to find the rules for subtracting integers, which means subtracting positive and negative complete numbers. Well, those rules still apply to this subtraction as well. So we're going to bring in all our rules for subtracting fractions, all right? Which means you have to have the same denominator, you subtract the numerators, you simplify if necessary. But then we're also going to bring in a rule for subtracting larger numbers from smaller numbers. But let's pretend first that we don't know that 2/3 is larger than 1/4. And maybe just by looking at it, you realize it's hard to determine that. Because they have different denominators, it's hard to determine if one is larger than the other. So the easy way to do that is to convert it to fractions with the same denominator. Okay, in this case, they would have a common denominator of 12 because 4 times 3 is 12. All right, and then you're going to convert 1/4 to 12 by remembering, okay, I have to multiply 4 by 3 to get to 12, so 1 times 3 is 3. All right, now I'm going to go on to 2/3, converting it to 12. 3 times 4 would be 12, so 2 times 4 would be 8. All right, and now it's really easy to see, okay, where it wasn't before, it's really easy now to see that the second fraction is larger. 8/12 is larger than 3/12. So we have a situation here where we're subtracting a larger number. Whenever you have that situation, all right, going back to those rules for subtracting positive and negative numbers, all right, whenever you have a situation where you're subtracting a larger number, we want to apply keep, change, opposite. And let me just kind of show you what that would look like by a pen because the animation doesn't really make that completely clear, all right? We're going to apply keep, change, opposite here to turn this to a friendly problem, to an addition problem. okay? You can't just simply turn that subtraction to addition. You have to follow the whole process, which means I'm going to keep the number in front. I'm going to change the subtraction to addition. I'm not going to stop there. I'm going to move on and get the opposite of whatever the next number is. So if it's positive, the opposite would be negative, just like that. So now I have a situation where I have 3 plus negative 8. And that's the same thing as 3 minus positive 8, but it's a little bit friendlier problem because we can go and use a tug line, all right, to understand that 8 is on team negative, 3 is on team positive, all right. Is there a war? Yes. The difference is 5, and the negative won the war, so we have a negative 5. Okay, so we have same denominators, and now we're going on to adding our numerators, because now we're just simply adding these fractions. I did 3 plus negative 8, which would be negative 5, all right? And then I'm going to keep my same denominator just like that, which is the 12. All right, so let's back up a step here. We had 3 minus 8. We did keep change opposite, which changed that to plus negative 8, all right? And then we just simply added up our numerators, all right? 3 plus negative 8 is negative 5, and we kept our same denominator, all right? Okay, let's move on to this one. I'm going to give you a chance to do this one, and this one's pretty clear now. We don't really have to, apply keep change opposite to understand that we have a situation that we need to apply keep change opposite. We have subtraction of a negative. Now remember, in that other video when I talked about adding and subtracting positive and negative numbers, if you ever see subtraction with the larger number being subtracted from a smaller number, you want to apply keep change opposite. Or if you ever see subtraction with a negative, then you want to apply keep change opposite as well, all right? So in this case right here, we want to apply that keep change opposite. But first things first, we want to turn these fractions, all right, into fractions with common denominators. So 7 times 5 is 35. So we're going to make fractions that have 35 as a denominator, all right? In order to get 2 7s to 35ths, we have to multiply 7 by 5 to get 35. So 2 times 5 is 10, all right? And then 5 times 7 is 35, so 3 times 7 is 21. So now we have a situation here where we've got 10 35ths minus negative 21 35ths. All right, now we're going to address the keep change opposite situation, where we're going to keep the first fraction the same. We're going to change to addition and make sure our next number becomes its opposite. So just again, it was 10 minus negative 21, so we're going to go 10 plus positive 21, keep change opposite. Then all we have to do is just add up the numerators and keep the same denominator, just like that. So we have 31 over 35 is our final answer. All right. So that's how you add and subtract fractions. Let's go ahead and address converting improper fractions to mixed numbers and then mixed numbers back to improper fractions. So here we have a situation where we have an improper fraction, 88 over 15, and we want to make that a mixed number, all right? This is different than adding and subtracting, all right? You want to, at the very end, you want to simplify your answer. If you ever have a numerator that's larger than the denominator, then you're going to want to convert that to a mixed number. And I have a little song if you want to. I'll go ahead and sing that song for you. I like mixed numbers and I cannot lie. You other brothers can't deny. When a fraction is there with the number on top that is larger than the number on bottom, you get stung because it cannot fly. You better simplify. Divide the number on top by the number down below, and then we say, let's go. I don't want improper fractions, girl. You better simplify. All right, silly song that hopefully pulls out what we need to do here. We need to divide the number on top by the number down below, all right? Divide the numerator by the denominator. So in this case, we've got 88 divided by 15, which means we have 5 holes inside of that we can pull out. So 15 will go into 88 5 times. So 5 times 15 is 75, and the 88 minus 75 is 13. So we're going to take that remainder, it's going to be our new numerator, and we're going to keep our same denominator that we had, all right? So keep the same denominator that you have, and 88 over 15 becomes 5 and 13/15, all right? You try this one, all right? Go ahead and pause this video and try 30 divided by 20, or converting 30 over 20 to a mixed number. So go ahead and pause it and try it yourself. All right. Hopefully you've unpaused it now. You're coming back and getting an example here. We've got 30 over 20. We want to convert this to a mixed number. We're going to take the number on top, the numerator, and divide it by the denominator. 20 will go into 30 one time. All right. 30 minus 20 is 10. And that's our new numerator. We're going to make a new fraction. 10 is going to go on top. 20 is going to go on bottom, just like that. And then we can simplify it from there. 1 and 10/20 becomes 1 and 1/2. All right. So there you go. Converting improper fractions to mixed numbers is as easy as dividing the numerator by the denominator. And then when you get to having a remainder down here, well, we can make that our new numerator of a new fraction and keep the divisor as our new denominator, the same denominator. Excuse me. All right, now let's go back. Let's go the other way. We've got a mixed number that we need to turn into an improper fraction. I like to teach the Texas method. The initials for the state of Texas are TX. All right, just like that, TX. And so I'm going to write those as lowercase, and it kind of looks like a plus and a multiplication. That's what I kind of want to get. So what we're going to do is we're going to take that TX, and you're going to write the T up in between the numerator and the whole number, and then the X in between the denominator and the whole number, just like this. All right, T and X. And then we're going to draw a loop all the way around, just like this. So let me just do it by hand so that you can see that, just in case. All right, 4 2/5. I'm going to turn that improper fraction to, this mixed number to an improper fraction using a Texas method. So I'm going to put T, X, all right, plus, multiply. And then I'm going to start a loop at the bottom and go all the way around just like that. Kind of tells me where I need to start my process and where I will end, just like this. And now you see that you just have instructions given to yourself. I need to multiply first, and then I'm going to have to add something, all right? So the way that I do this is I'm going to start down here. I've got 5 times 4. That's going to be 20, just like that. And then I'm going to add straight across the top. 20 plus 2 is 22. And then I'm going to keep the same denominator that I have, just like that, 22/5. I'm going to watch the animations here. All right, again, we're starting at the bottom. That's where our loop started. So we have the the denominator multiplied by the whole number. That's 20. All right, just like that. And then we're going to add straight across. 20 plus 2 is going to be 22. And then we'll keep our same denominator that we had before. All right. You try this one. Pause this video. You try it. Give yourself the self-gratification of knowing that you know how to do this, all right? And then come back, all right? I'm going to go ahead and start it now. 2 2/5. Again, I've got my Texas method here. I'm going to go ahead and write the T up by the 2 and the X down by the 5. That's going to be a plus and a multiplication. And I make a loop all the way around. So I'm going to start down here. I've got 5 times 2 is 10. And then 10 plus 2 across the top is 12. And then we're going to keep our same denominator just like this. All right. I hope you enjoyed this lesson. If you have any questions, you can comment down below. Actually, I think this is all made for kids, so you can't comment down below. I may turn that off at some point, so if you can see the comments, you can ask me questions down there below. But I want to encourage you, go ahead and hit the subscribe button that's down below so you get more middle school math videos. And I hope you all have a great day. Bye-bye.